All right.
35 degrees Celsius.
Liam, let me know if I'm in the thing there.
You are.
Okay. If a process has a positive delta G, how can that process occur? It's kind of the exact same question, but opposite. So I asked you, how can a negative delta G, which we expect to work, not work? How can a process that has a positive delta G actually happen, but we would not expect it to? So now we have a better idea how to answer it. There's usually one pretty easy answer, sort of, based on the last question. The reason this doesn't occur, entropy or energy or activation energy, the collisions, something's not happening correctly, so it's not favorable, but yet it still happens. I'll give you a great example. Blow your mind. This is not supposed to happen. Photosynthesis, not supposed to happen. It's positive delta G, huge positive delta G. So according to chemistry, photosynthesis should not happen and we would all die.
You have to input the energy to create the ATPs.
You hear these guys? This is good stuff. So how does it happen then? Let me ask you guys this question. Is there like certain wavelengths that photosynthesis happens at a more efficient manner? Yes. So what is the wavelength? What is that doing? What is it giving you? Energy. That's it. That's the answer. That's the answer. Apparently, how does our body get energy?
Metabolic recharge.
Isn't it like ADP to ATP?
Yeah.
Okay. That process of converting ADP to ATP, positive delta G as well. So we're not supposed to do that either, but we do it, or else we would just be a blob. We wouldn't be able to move. Okay. So here's the concept. Not everything that's thermodynamically favorable happens. Not everything that is not favorable doesn't happen. It depends on the situation. So the easiest way to answer this, and usually this is the easiest answer, is energy. Energy is provided to overcome constraints or constraints. Okay.
Catalyst factor in somehow?
Yeah. I know there's a catalyst, I think, involved with the ADP, ATP. You guys would know. I don't know. Maybe I'm wrong.
You have to get the hydrogen.
Yeah. So what I'm trying to get you to understand here is that with some of these concepts in this class, the AP test is really focusing on, and I like this. So listen. I like this part of the class, that we're talking about something that you understand or relates to like actual real life, photosynthesis, ATP. These processes shouldn't happen. Why do they happen? There's some source of energy. So certain wavelengths of light coming from the sun really give that photosynthesis reaction enough energy to happen. Other wavelengths don't. So it needs a certain amount of energy specific from those wavelengths. There is another specific type of catalyst or something in your body that helps that ADP and ATP. I'm not an expert, but that's just the gist of it. Okay? So that's important, I think, that you understand that. Okay. And the last thing I want to end with here. Delta G in equilibrium. Okay. There is an equation on your reference tables. Delta G equals negative RT natural log of K.
Gross.
If we have delta G equal to 0, that means K is equal to 1. If you understand some math, does that make sense to you?
No. Yes.
What's the natural log of 1?
0.
What's 0 times anything?
0.
There you go. Delta G is negative. All right, you know what? Let's do it this way. Less than 0. And K is going to be, greater than 1. If delta G is negative, it's going to be thermodynamically favorable. We want to make a lot of products, so that's positive, or I mean a big K. And if delta G is greater than 0, then K is less than 1. This summarizes everything you've learned up to this point. Just those three little lines. If you understand what thermodynamically favorable means, if you understand the equilibrium constant, this is how you relate them. Okay? So, every reaction we've talked about with equilibrium, you can find the value of delta G. Then you can find the value of K. So, this equation we're going to be practicing with. You have your acid-base quiz due Monday, right? Labs due. Oh, did someone tell Bree the 0.95 grams of NaNOH? All right, everyone got that, right? All right, I'll tell you what. I won't give you any extra homework. But wait. The price you pay for that is Monday. I'm giving you like 2 worksheets and book work. Do you want some of it now?
No. Honestly, I'd rather just
How about I just give it to you now? I'll give you the worksheets now, and they're due Tuesday. And it's up to you what you do. Okay.
That makes me feel guilty. Justin, that is so snow. I don't know. Oh,
Okay, hold on. Here, just come on up and get them. It's easier.
I know, I was like, I'm fine.
Yeah.
It's okay.
That's it.
I'm just so late.
Break out.
Yeah. Oh, wait.
Yeah, we need whatever. Yeah. We each need.
Yeah.
Worksheet's probably done.
He would be that kid. Slade would be that kid.
Eddie knows that it's just not our This is not okay.
Sandwiches.
I'm nice.
All right, those are due Tuesday.
I would say